This is the advanced level problem on our statistics quiz number 3, which states, each of 25 adult women was asked to provide her own height y in inches and the height x in inches of her father. The scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some of the xy pairs were the same. The equation of least squares regression line is y hat equals 35.1 plus 0.427x. Part A asks us to draw the least square regression line on the scatter plot above. So now that we have the least square regression equation, which I blew up here so you can see a little bit better, we can start to solve for the xy pairs by plugging in different x values, or heights of fathers. So the first value I chose was 70, and if you plug that in for x and solve for y hat, you get 64.99, and you can make a coordinate pair. If you do this a couple more times, you can end up with a couple more coordinate points, which then you can then graph and create your line. So here you can see I plotted the points in orange from our table, and I put a solid line through the actual value range of the scatter plot and a dotted line for the rest, because the least squares regression line can only accurately predict through the given range. But I included the rest so you could see the full path of the regression line. Part B says one of the father's heights was 67 inches and his daughter's height was 61 inches. Circle the point on the scatter plot above that represents this pair, and draw the segment on the scatter plot that corresponds to the residual for it. Give a numerical value for the residual. As you can see on the graph, I've already circled the point that lands at 67x and 61y, and given the residual line segment here. To give a numerical value for the residual, we'll have to re-look at the least squares regression line, and then we'll plug in the father's height, 67, for x, and calculate the predicted height of his daughter at 63.709. From there we plug that value into our residual equation, which is actual minus predicted, which gives us r equals 61, the actual, minus 63.709, the calculated predicted, and we get a r value of negative 2.709. The residual value is negative, which tells us that the actual point is below the least squares regression line, which is clearly shown in the graph. This is because the residual value stands for the difference between the actual and predicted. Part C says, suppose the point x equals 84 and y equals 71 is added to the data set. Would the slope of the least squares regression line increase, decrease, or remain about the same? So the first thing that I did was plotted this point on the graph here. Then, from there, I solved for the predicted value according to the least squares regression line. If we plug in 84 for x, we get a y hat, or predicted value, of 70.968. Very close to 71. So to answer the question, I said, this new point, 8471, seems to follow the linear trend and is extremely close to the predicted value, 8470.968, according to the least squares regression line. Therefore, the slope would remain about the same. Part D asks, will this cause the correlation to increase, decrease, or remain the same? Well, if we look at where the point is on our graph, we can see that it matches the overall linear pattern fairly well and is located right about on the least squares regression line. We can also see that the point is pretty far separated from our bunch right over here. The x value is fairly high at 84, and so given what we can see from the graph, I said the point 8471 fits the overall pattern very well and has an x value that is far from the average x value, so the correlation would increase.